Today we're going to be describing variability within a dataset using the interquartile range. Our objective today is that we can calculate the median of the data and describe the variability in the data by calculating the interquartile range. Finding the interquartile range is another strategy for mathematically measuring variability, similar to how we used mean absolute deviation. To best understand this, let's look at a sample set of data. This is a sampling of data from our French fry example in Lesson 12. Our goal is to find the interquartile range of this data set to measure the variability between bags of fries. To start, we're going to need to order our data from smallest to largest. Now that we've got our data ordered, let's identify the median or middle number of our data set. The median is an important part in determining the interquartile range because it marks the halfway point in our data. The median of this data set is between 80 and 84. When we average these two values, we get our median of 82. Before we go further, let's break down the term interquartile to better understand what it is we're solving for. When we look at the word interquartile, we can see it is made up of two parts, inter, meaning inside of, and quartile, meaning quarters. Let's first break out our data set into quarters. This means that we're going to divide it into fourths, or chunks of 25% of the total data. The median was important because it gives us the halfway point of the entire data set. Now we have to divide the two halves in half, which will divide our entire data set into fourths. Because our median came from averaging 80 and 84, we still include both 80 and 84 on their respective halves of the data. Let's start by focusing on the left half of the data set. We again need to find the median, but this time we only find the median of this half of the data set. Begin eliminating the smallest and largest numbers on the left half of the data until we found the middle point. The median of our left side is 77. Now let's repeat this process for the right side of the data set. The middle two numbers are 87 and 88. This gives us a median of 87 and 5/10. We've now divided our data set into quarters. Let's highlight these to make this easier to see. Each quarter contains 25%, or 1/4 of our total data. For example, the yellow quarter contains 5 data points out of our total of 20 data points. 5 out of 20 simplifies to the fraction 1/4. Let's look back at the word interquartile. We split our data into quarters, fulfilling the quartile part of the term. When it says interquartile, however, inter means the inside quarters. Specifically, we're measuring the range across the two inner quarters, or the middle 50% of our data. To show this range, we're going to find the distance between the two quarters and represent this range with a single number that shows the difference. In this case, our interquartile range runs from 77 to 87 and 5/10. To list this as a single number, we must find the distance between these 2 points. The difference between these 2 points is 10 and 5/10. We can say that the interquartile range of this dataset is 10 and 5/10. We can also represent this on a dot plot. This dot plot contains the same data listed in our dataset above. I've drawn blue lines to represent the interquartile range. Notice that in the dot plot, our quarters don't appear to be equal. Let's highlight this for more clarity. While you can see that each quartile of our data covers a different distance, they all have an equal number of data points, 5, within their range. The larger our interquartile range is, the more our dataset varies. The smaller our interquartile range is, the less variation there is within our dataset. To find the interquartile range, you must first find the median of the entire dataset. The median represents the middle point of the dataset. Find the median of each half of the dataset to divide it into quarters. Finally, find the interquartile range by subtracting the endpoints of the two inner quarters. We mentioned earlier that both mean absolute deviation and interquartile range measure the same thing, the variability of a dataset. So how do we know when it is best to use one over the other? Mean absolute deviation measures the average distance a data point is from the mean. This works well for data that is relatively clustered together, but produces less accurate results for data that is skewed or has extreme outliers. In the example above, the mean absolute deviation is thrown off because of a few outliers, even though most of the data is at the lower end of the spectrum. This skews the mean absolute deviation and makes it appear that there is far more variability in the dataset than there really is. The interquartile range is based off the median, which is a better measure of center when we have skewed data or data with a few extreme outliers. Notice how the interquartile range is based much more closely around the large clusters of data when compared to the mean absolute deviation. As a general rule, we want to measure variation in a dataset with the interquartile range when there are a few extreme outliers that would otherwise skew the mean.